Hey everyone, so today we are going to focus on graphing quadratics again, but we're going to really focus on the zeros and the vertex and some symmetry issues instead of using a table, because using the table is a little tedious and unnecessary most of the time because we can just use the other information we have. So let's start by looking at that equation, y equals x squared minus 10x plus 24. I want you to pause the video and write down everything you know about it. So the first thing I recognize is that x squared has a positive coefficient, so it is upward facing. So the parabola is going to look like that. I know that the y-intercept is at 24, your c value. If I factor it, that's a pretty easy factoring problem. My zeros, or my x-intercepts, are at x equals 4, x equals 6. My vertex, negative b over 2a, negative b over 2 is 5. So the vertex is 5, comma, now what do we get if we plug in? 25 minus 50 plus 24. That's 49 minus 50. So negative 1. My axis of symmetry is x equals 5. Right. There's some other stuff you might be able to come up with, but those are the important aspects of this graph. Okay, so here's kind of just a general informational page. If you're really unsure about any of this, write it down. If you don't write it down, that's okay if you know it. We learned pretty much all of this already. One of the things we didn't really talk about in the last lesson was a parabola can have two x-intercepts, one x-intercept, or no. So we talked about 2, right? It crosses twice. We talked about it never crossing, so that's if it's like something like this. That's when our underneath the square root is a negative. It also can touch once. So if the vertex is on the axes, it'll only have one solution. So there are different, so that kind of gives you different information. It depends on the setup of the problem. Our y-intercept is at C. They're always symmetric. So just lots of information here. All right, so here's our first graphing problem. So we're going to start by finding the x-intercepts. So x-intercepts, we're going to set this equal to 0. We're going to factor it. This is a nice, easy factoring problem. X minus 1, x minus 5. So x equals 1 and x equals 5. So those are my x-intercepts. So 1 and 1, 2, 3, 4, 5. All right, what is the axis of symmetry using the x-intercepts? So remember, it's symmetric. So if you add those together, 1 plus 5 divided by 2, we get 3. So the axis of symmetry is 3. We could also do negative b over 2a. Right, so that's negative 6 over 2 times 1. So that's also 3. So the vertex is 3, comma. Now we're going to find f of 3, plug in. So that's 9 minus 18 plus 5. That gives me 14 minus 18, which is negative 4. So 3, negative 4. 1, 2, 3, 4. My y-intercept is 5. 1, 2, 3, 4, 5. Okay. So find the symmetric point to the y-intercept. So the y-intercept, the symmetric point, is if you reflect it over your axis of symmetry. So let me show you. If I'm going to draw on my parabola as accurate as I can. All right, so my axis of symmetry, I'm going to draw it in red, is that, right? So if I take my y-intercept, this 0.5, and I reflect it over the line x equals 3. So 1, 2, 3, 1, 2, 3. It's another because it's a reflection, it's another point on the graph. So we have the point 0, 5, and then we reflect the point 0, 5 over x equals 3. So it's 3 and then 3 again. So that's 6, 5. Basically, all you have to do is take the vertex, which is 3, the x value, and double it. If you double 3, you get 6, and that's your new x value. All right, so and those are all the important points. So this is like an easy way of graphing it using just those important information: the x-intercepts, the vertex, the y-intercept, and then its symmetric point. The issue comes up is this is a really easy problem, right? These can get really gross pretty fast. Okay, so x-intercepts. I rarely use the name x-intercepts. Sometimes I'll say a word and then I'll be like x-intercepts because I don't use that very often. The two words that I typically use are the zeros because that's where y equals 0 and the roots. I actually usually use the roots. So the roots of the graph are where it crosses the x-axis. So just other vocab. It's nothing new, just another way of phrasing x-intercept. All right, so here's the next one. So this one is a little gross, which is why you notice I didn't give you a grid. So it is factorable. It comes out like decent, but it's going to be like some of the numbers are going to be a little weird, which is why I didn't give you an actual grid. We're just going to do lines. All right, so I want you to pause the video, find the vertex, find the roots, find the y-intercept, and the symmetric point. Okay, so for the vertex, we're going to do negative b over 2a. So negative b, negative 3 over 2 times 2. So I got 3 over 4. I'm going to plug 3. When I plugged 3 over 4 in, I got negative 10.125. So it's a decimal, which is expected. That's negative 10 and an eighth, I think. For the roots, this is factorable, so 2x, x, minus 3 plus 3 equals 0. So I get x equals 3, and x equals negative 3 over 2. My y-intercept is 9, negative 9, sorry. And then my symmetric point, remember, we're going to take 0, 9, and reflect it over the line, x equals 3 over 4. And what ends up happening is we basically double the x value. So 3 over 4 doubled is 6 over 4, right? Which ends up being 3 over 2. So 3 over 2, comma, negative 9. All right, so we're going to graph this. Again, because this is like weird, we're just going to do the best we can with it. All right, so for my x values, I only need to go up to 3. 1, 2, 3. 1, 2, 3. And then my y's, I need to go down to negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So just do the best you can with it. It's not that serious. Okay, so I've got 3 over 4, negative 10.125. I went down to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3/4, just around close to 1 and just below 10. I've got my roots of 3 and negative 3 over 2, so that's negative 1.5. I've got negative 9. That's negative 10, so negative 9 is here, and then 1.5. I'm just going to connect my dots. It's not beautiful, but it's a problem. And since we have all that information, you don't have to label. You can if you want, right? 3 over 4, negative 10.125. However, notice I have all the information written down. If you just give me that graph and none of this information, I can't guess. You need to show me that you understand the material. Okay, so pause the video and try this one on your own. This one's a little easier. All right, so negative roots. The roots. The roots are on fire. It's a song from the 90s. So I factored it, set it equal to 0. I get 8 and negative 1. So x equals 8. X equals negative 1. My vertex, negative b over 2a. So that's 7 over 2, which is 3.5. Let's plug 3.5 in and see what we get. I get negative 20.25. Ugh, well, that's not helpful. Okay, y-intercept, 0, negative 8. And symmetric point, I'm going to reflect that over 3.5. So if you double 3.5, you get 7. So 7, negative 8. Axis of symmetry, x equals 3.5. All right, so now my graph only goes up to 10, so I'm going to just double everything. I'm just going to scale it, make that 2, 4, 6, 8, 10, 12, 14, 16, 18, and negative 20. All right, so I've got 8, negative 1, 3.5, negative 20.25, so it's like here. 0, negative 8, and 7, negative 8. So this graph looks a little weird too because note the scaling is different, right? So I scaled my y value only. So sometimes it's hard to like really judge the graph well because the scale on the x-axis is different than the scale on the y value. So if you don't scale both of them, just know that sometimes your graph might be look different than others, right? If I were to scale the other one up by 2, it would end up being like super skinny if I did it that way. But I didn't. So just know that that can affect your graph as compared to someone else's. No, my y value would be, my vertex would be like over here. All right. So it all depends on what you do. Don't freak out if you see someone else's graph and it looks a little different, or even my graph. If you're like, well, that's not how I did it, that's okay. If you're scaling it and it looks a little different, it's not a big deal. Don't freak out. All right. All right, pause the video again. Try it on your own. Again, I'm giving you some nice factoring problems. Basically, this is the method I use if it's factorable and the vertex is weird. So depending on the problem, that depends on which method I use. With factoring, it's more specific. Like, oh, you have to use this method. But with graphing parabolas, but dependent on the way the structure of the problem, is it factorable or not, will depend on what I do. So negative b over 2a, so that's negative a half. What do I get when I plug in negative a half? I got negative 6.25. Y-intercept is negative 6. If we reflect that over the line negative a half, you get negative 1, negative 6. Axis of symmetry, negative a half. Alright, so we got 0, negative 6, 1, negative 6, and then the vertex is like right in there. So it looks kind of weird. I'm going to connect all those dots the best I can. That's it. So again, I use this method when my vertex is awkward, decimals, and it's factorable. That's the most useful. This is the most useful method when it looks like that. All right. Again, pause the video. Try it on your own. Let's see my roots. 3x, x equals 0. What do we get? 2. 3 times 2 is 6. Minus 4. gives me 2. So my roots are 4/3 and -2. My vertex is -2 over 2 times 3. So it's -1/3. And then let's see what I get when I plug in. I got -8.3 repeating. So -8 1/3. My y-intercept, 0, -8. Reflect that over -1/3. If you double -1/3, you get -2/3. -8, my axis of symmetry, x equals -1/3. Alright, so my x values only have to go out to like 2. So 1, 2, 1, 2. And then down to -8. -8. We'll do like -4. Yeah, that's good enough. Alright, so the roots are 4/3, so that's 1 1/3, so like there. -2. -1/3, -8 1/3, so it's like here. 0, -8. This is not accurate. My spacing wasn't very good. That's what happens when you're just drawing it by hand. I'm gonna fix this. It should be like there. It's a little better. Alright, that's it. So it's not very hard. The vertex is just weird and annoying. Alright, next one. Do it on your own. You got this. My roots, let's see. -2x. I hate when the x is negative. That's going to be -1, -5. No, the 5 has to be positive. Oh, those are both positive. So that's 5x minus 2 gives me 3. Okay, so I get -1 and 5 over 2. Yeah. Vertex is -3 over 2 times -2. So the 3 over 4. Plug in 3 over 4. I got 6.125. Y-intercept, 0, 5. Let's start with all that. So my roots are -1, 5 1/2, 5 over 2, so it's 2 1/2. 3/4, positive 6.125. So it's just before 1 and just above 6. So like there. Oh, my pen. My stylus did not work well there. Let's try that again. Yeah, like that. My y-intercept is 5. So now remember, if I reflect 5 over 3 over 4, that becomes 1 1/2, right? So we want the distance for between those 2 points, right? This point and this point. We want their distance, half of their distance, to be the vertex, right? So that's why I always double. So that is 1 1/2, comma 5. Okay, that was ugly. That's it. Axis symmetry, x equals 3 over 4. And so basically, all right. So now what I want you to do is we've kind of talked about this briefly. What do each of these look like? So x squared is your basic parabola. It's the parent function. Just looks like that. What happened on our homework the other day when we had 3x squared? It made it skinny. So it was like this. What if it was -2? it's skinny, but it's also upside down. Not quite as skinny as the 3. So it's skinnier than x squared, but because of this negative, it's upside down. And then the 1/4, because it's a fraction, right, it makes it wider, right? So basically what happens is these numbers affect the y value. So it makes the y value go up 3 times as fast. The y value go up 1/4 as fast, so it's wider. It's not going up as quickly. And that is it. All right. Have a fabulous day. Email me if you have questions.